From here, the question says that the diameter of a pipe at the section 1, right? 1. The diameter of a pipe at the section 1 and 2, meaning section 1 and 2 are given respectively to be 200 mm, and 300 mm. If the velocity of the water flowing through the pipe at section 1, if the velocity of water flowing through the pipe at section 1 is 4 meters per second, find the quantity of flow through the pipe and the velocity at section 2. Solution: it is always advisable, draw your question, represent your question diagrammatically, meaning draw a diagram for your question, right? Now, giving data clearly from that question, I have section 1 and section 2, right? Now for section 1, what's the given data? For section 1, the diameter D is given to be what? 200 mm. Okay, velocity is given to be what? 4 meters per second. Is that all? Yeah. All right. Section 2. For section 2, what do you have? Section 2, you have diameter of 300 millimeter with an unknown velocity. What else? The question says that find the quantity of flow in the pipe, meaning Q, and what? V2. Now, what this means is that for section 1, you have diameter 1 and you have velocity 1. For section 2, you have diameter 2 and velocity 2, right? Now, from here, what unit are you going with? Millimeter or meter? Meter. You can go with millimeter or meter, but it is easier if you go with what? Meter. Now, this is your diameter in section 1 and section 2. Convert it to what? Meter. And how do you convert to meter? Divide all 3 by what? 1000. So meaning that our diameter in section 1 in meter, what do you have? 0.2 meters. In section 2, what do you have? 0.3 meter. Now, you've listed your given data. The next thing to do is to draw your diagram. Before then, for section 1, what is the diameter of section 1? 0.2. What is the diameter of section 3? 0.3. Meaning that if you are drawing your diagram based on this given question, your section 2 will be bigger than what section 1. So this is also a track mark, not only in this course. So get that. So drawing this diagram, you have your pipe in this manner. This is section 1. This is section 1. This is section 2, right? And Q is entering section 1, right? Q1 is entry, okay? Q is entering section 1 and Q is also leaving what? Section 1. But this Q is the inlet. Let's denote it as what? Q1. This Q is the outlet. Let's denote it as what? Q2. Now, when you are solving theory question, to know if you are correct is that at the end, what makes up your quantity of flow? Q is equals to what? Area times velocity. Meaning, by the time you know the area and velocity of section 1, use it to get the quantity of flow. It must be the same as the what? quantity of flow that you are going to get here using the area and velocity here. You get what I'm saying? With that, you will know that you are correct. But if it is not the same, it means what? You are wrong. And it must be the same following continuity equation. By continuity equation, we said the masses will remain constant if no flow is added or removed. Now we said this guy, this key one has entered this pipe. You know, this is your pipe. This key one has entered this pipe. By the time this key one is leaving, the magnitude must still be this key one. I get what I'm saying? Yes. It will be different only if another fluid is added or removed, and you see that in the next example. That's what I'm saying. So that's it. Now from here we said meaning Q is equals to AV. What this means is that Q1 is equals to Q2, which is equals to what? Q. You can use either this or this to get the first question. Have I given you the question? Question 1 is what? Calculate the quantity. Yeah, calculate the quantity of flow in the pipe. Meaning either you use Q1 or use Q2, you get the quantity. You get the quantity. Now from here, which one do you think you are going to use? Section 1, because from section 1 we can compute the value of the area and the what? Velocity. Velocity is given. We can compute the value of area. Take note, area is equals to pi d square over 4. Pi d square over 4. That's the formula for area. Now let's solve the area of section 1. Solving for the area of section 1, meaning I have pi all into brackets, substitute your diameter, meaning 0.2 all square divided by 4. You put this in your calculator, your area in section 1 is what? 0.03 meter square. Approximately, we have this, right? Approximately, we have this. Meaning, to get the quantity of flow in this pipe, meaning the flow through this pipe, the flow through this fluid, to get the quantity using Q1, that becomes what? Q1 is equals to A1 multiplied by what? V1. Substitute Q1 is equals to, what's the area? We've calculated that. We got 0.03 times the velocity given 4. What's the answer? 0.12 meter cube per second. Meaning the flow inside this pipe is what? 0.12 meter cube per second. That's question 1. This is question 1. Now for question 2, the velocity of, find the velocity of section 2. Now, how do you get velocity of section 2? Using continuity equation, we know that Q1 is equals to Q2, meaning A1 V1 is equals to A2 V2, right? Call this equation 1, call this equation 2. From equation 2, make V2 the subject of the formula, it becomes what? V2 is equals to A1 V1 divided by what? A2. Call this equation 3. All this means is that to get your velocity of section 2, use equation 3. But this equation 3 now, we already know area 1, velocity 1. What about area 2? Have we calculated area 2? No. So let's solve area 2. Solving area 2 using the same formula, meaning area 2 is equals to pi all into brackets. What's your diameter? 0.3 square divided by 4. What's the answer? 0.0 meter square. Yeah. Now substitute each parameters into equation 3. By doing that, your V2 becomes what? Area 1. What's area 1? 0.03 multiplied by V1. 4 divided by A2, 0.07. What's the answer? 1.71 meter per 1.714 meter per second, right? Now, in place of this unknown, what's the value now? 1.714 meter per second. And earlier we said that Q1 is equals to Q2, which is equals to what? Q. Now, we found the quantity of flow through this pipe using section 1. Now, let's use section 2. It must be the same. Now, using section 2, meaning that Q2, identify what's the area, what's the velocity. The area is what? 0.07, meaning 0.07 multiplied by the velocity, 1.714. What's the answer? You must get this guy. What's the answer? 0.12 meter cube per second. You don't need to do it. Just to confirm. And what this means is that you can actually relate this to continuity equation that says that the flow entering is equal to the what? The flow leaving. Now let's take example 2.